Hi everyone. In today's video, we will be covering Chapter 3, which is about measures of central tendency. Measures of central tendency are statistical metrics that describe the center point or the typical value of a data set. And there are three primary measures of central tendency that we will be covering, and those are the mean, median, and mode. So starting off with our first measure of central tendency is the mean, or what is also commonly referred to as an average, which is a measure of central tendency that summarizes a set of data points by calculating their arithmetic average. And in order to calculate the mean, all that we have to do is add together all of the values of the observations within a particular sample or population, and then divide that by the number of people that we have within our data set. So for example, I conducted a brief survey that asked 14 students, on average, how many hours per week do you spend watching TV? And here are their responses here, recorded on the left-hand side. And so in order to determine what the average number of hours spent watching per week is, all I have to do is add together all of these observations and then divide by the total number of observations. Again, I asked 14 students, so that's where I'm getting that number here. If I add together all of these hours, I get a total of 94. And then again, all I have to do is divide by that total number to get an average of 6.714 hours. We can also calculate a mean or an average value using a frequency distribution. So if you recall from the last video in Chapter 2, a frequency distribution is a great way for us to organize and visually display data for a single variable. In this case, our single variable is the hours spent watching TV each week. So I'm using this same data set I did on the last slide when I asked 14 students, again, on average, how many hours of TV are you watching per week? You can see here down I have my same total of 14, but we're just visually displaying this information in a slightly different format. Because of that, I have to calculate my mean or average in a slightly different manner. But again, if you look here at the conclusion, our average value is going to remain the exact same. We're using the same data as the last slide, but we're just showing it in a different way, again, through a frequency distribution. This same formula, in order to calculate a mean, is the exact same that you saw on the last slide. We just have to modify it slightly to account for this frequency distribution. So let's take a look at that here. The first row of my frequency distribution is indicating that I had, in my 1 hour category, 2 students report that they watch on average 1 hour of television per week. Recall that our frequency here is showing how many observations fulfill a certain requirement. In this case, I had 2 students respond that they watch 1 hour per week. So looking at my formula down here, I see that I had 1 hour listed here, but I had 2 observations, so I have to multiply that by 2. Essentially, the same math is no different than if I showed on the previous slide that I had 2 observations that were both 1s in value. So 1 times 2 is 2. If I add together 1 plus 1, I also get 2. The second part of this observation is accounting for those that reported that they watched 2 hours of television per week. And I only had 1 student indicate that. So for every 2 hours, I had only 1 student. In this case, I had 3 students say that they watch 3 hours, so on and so forth until we account for all of our values. When we do that math and add all of those values together, we still get that total of 94 hours. So this is a good way for us to check our math as well from the previous slide. All I have to do when I calculate that final value is divide by our total number of observations, which is 14, to get 6.714 hours on average among these students. Again, the math is the same. We just slightly had to go about it differently because of the format the data was presented, but ultimately we get the same result. In terms of using the mean as a measure of central tendency, there's a few disadvantages that I want to go over. And so this is something to keep in mind as you're analyzing data, either in a journal article or a newspaper article or anywhere you see it on media. This is something to keep in mind when you're looking at average values. So one of the key disadvantages of using the mean or the average value is that it can be easily influenced by outliers or extreme values. This is especially the case if we have a very small sample size. So let me give you an example here. Let's say that I asked a group of individuals what their net worth is, and those are all listed here. We could calculate what that average is as well. So if I added up all of these net worth values together and divided it by 10, again, because I asked 10 people in this case, again, 10 observations, so that's where I'm getting my total value down here, I would get an average net worth value for this group of $33,250. But let's say I add one more observation to our data set, and that is our friend Jeff, or Jeffrey Bezos, who has an average net worth of approximately $196 billion. All that I did in this case was add one more individual. So instead of starting with a group of 10, I now have a group of 11. But because Jeff's net worth is so much more than everyone else within the data set, his observation alone, because it's an outlier, increases our average of this data from $33,250 to over $17 billion. So this is something important to keep in mind as you read about this in media, journal articles, or any other part of your studies, is that when you use and report a mean, or an average in this case, if you have a small enough group, there might be some outliers that do affect that overall average. The second type of measure of central tendency that we're going to be going over is the median. The median is a measure of central tendency that represents the middle value of a data set when the values are arranged in ascending or descending order. In other words, that means either from highest to lowest or lowest to highest. How we go about this is that we divide the data set into two equal halves, with 50% of the values falling below the median and 50% going above it. In order to calculate this, we'll just follow the steps that we had on the previous slide. So, using that same data set about asking our class students how many hours per week are they watching television, we can calculate the median of that data set as well. In this case, one of the first things I like to do when calculating the median is figuring out if I have an even or odd number of observations. In this case, if I have an even number, which we do because we have 14 students, we will have two middle observations. When we have two middle observations, to find that middle value, all we have to do is add those together and divide by 2. So let's look at this in the context of this problem. If I order these from lowest to highest, which is what I did here, here's my original raw data to the left-hand side. All I did to get to this point was order it from the lowest number of hours to the highest number of hours. And because I had that even number again, I'm going to have two middle observations. In this case, I have the 7th observation and the 8th. Because again, we don't have an odd number, so it is our middle point. With the 4th and 5 hours, all I have to do to figure out the median number is add those two together and divide by 2. Again, we're only dividing by 2 in this specific circumstance because we have that even number of observations. So again, that's one of the key aspects I like to look at prior to even starting my calculation for the median. Let's also take an example of how we would calculate the median if we had an odd number of observations, which we do in this case. So I just changed the number slightly and also removed one of the observations in terms of asking students about their average number of TV hours being watched. So in this case, I just removed one, so I have 13 individuals. Same step here where I'm taking our raw data or values and just ordering them from lowest to highest. And because it's odd, we will have one middle observation. In order to do that, again, all I did was order these, and knowing that I have that middle value of 13, I know that I am looking for my 7th observation here because that's the middle. I have 6 observations above this and 6 observations below it. So I'm at that 50% or middle threshold. Another way to figure out what your observation is going to be is this formula here. So in this case, if you take n, which was 13 for us, we had 13 students that we asked, add 1 and divide by 2, we know that it's our 7th observation that we're going to be looking at. Again, 6 above, 6 below. So we know that this is our middle point, and our median value in this particular data set is 6 hours among these students. So just a slightly different way. It actually makes our lives easier. I would actually recommend just ordering these if you can, knowing what that middle value is, having that equal 50% value above and below, and knowing that that's your middle point. We can also calculate the median from frequency distributions. So similar to how we did with the mean, this is where our cumulative frequency comes into play. So I told you at first to ignore that last column for calculating our mean because we didn't need that information at that point in time. To calculate the median, we do. What this cumulative frequency does is counts up all of our observations as we keep going. So in this case, I started with 2 students saying that they watch 1 hour of television. I have another student, just one, who said that they watch 2 hours. So that's where I'm going from 2 to 3. I'm just doing 2 plus 1 equals 3. If I do 3 plus 3, I get 6. 6 plus 1 is 7, so on and so forth, all the way until we get our total cumulative frequency, which should always match our total number of observations. In this case, we're going back to our example of 14 students. So in order to find that median value, we know that just by looking at this frequency distribution that we have an even number. We have 14 students that we're taking a look at. So we can use our formula to determine that it would be the 7th observation, theoretically, that we'd be looking for. But since we have that even number, we're going to have to do that same step of finding both our 7th and 8th observation, adding those 2 values together and dividing by 2. So where do my 7th and 8th observations come into play here? Looking at my cumulative frequency, I know that my 7th value is taking place at 4 hours of TV watched per week, and my 8th value is occurring at 5 hours of television watched per week. That's where I'm getting both of these values here. So 4 plus 5 equals 9. Divide by 2, which are just those middle 2 observations, to get 4.5 hours. So same format that we did for calculating the median in just a slightly different manner. In terms of measures of central tendency, we've so far discussed why the average or the mean value is not always the best option for us in terms of describing the center point of a data set. Reason being is that the mean is influenced by extreme values and outliers. However, one of the advantages of using a median to describe those center points is that it is resistant to outliers and is typically a lot more representative of the typical values of a data set in comparison to the mean. Let's take a look at why the median value is a lot times more advantageous for us to use than the mean. Let's go back to our example about average net worth of our group. We already discussed why adding our friend Jeff here at the bottom would be really problematic in terms of adequately and accurately displaying what our average net worth is for our group. We saw that our original mean before adding him in was approximately $33,000, whereas when we added Jeff's net worth to our data set, it increased to over $17 billion, which is not a good indicator of what the average net value was of all of the individuals that we had within our sample. However, if we take the median value instead, we can see that the old median before adding Jeff in was $31,000, whereas even after we add in his value of net worth, we get a new median value of $32,000. Again, the median represents that true 50% point. What is that middle value? In this case, if I were to order all of these net worths from highest to lowest, Jeff's would be at the very, very top. But remember, I'm only concerned with what that middle value is, so it doesn't skew and it doesn't pull all of the averages, how it does in the mean, up, because the middle point's going to remain relatively similar. So this is an example of where the median would be a lot more accurate of our overall group in comparison to the mean. The last measure of central tendency that we will cover in today's lecture is the mode. The mode is a measure of central tendency that identifies the most frequently occurring value within a data set. And unlike the mean and median, the mode can be used with both numerical and categorical data. A data set may have one mode, but it could also have more than one, and we'll take a look at that as well. It's also possible for there to be no mode within a data set if none of the observations have the exact same values. In order to calculate the mode, let's revisit our example of how many hours on average our students are watching television per week. And so what I'm looking at in this first column here are just the raw numbers that were reported. So by these 14 students, how many hours on average are they watching television per week? I personally find it helpful when trying to identify the mode to put the observations in numerical order. That way I can quickly tell how many of my observations are matching one another, and I can compare them to different sets of observations that might have multiples as well, such as we had 2 respondents say that they both watch 1 hour, 2 say that they both watch 10 hours, and 2 that say they watch 12 hours. But what I'm seeing overall in that my most common value is 3 hours. In this case, I had 3 students respond that they watch on average 3 hours of television per week, so that represents our mode. Keep in mind that depending on the data set, we could potentially have more than one mode. So let's say I had a sample of 15 students instead of 14, and that 15th person came in and said they also watch 12 hours of television per week. Then I would have 2 modes. In that case, it would be 3 for 3 of my students watching 3 hours per week. And I'd also have a mode value of 12 because I also had 3 students report that they watched 12 hours on average of television per week. There could also be a scenario in which we don't have any mode. So if all of these observations were different numbers and values, so we didn't have anyone matching up, it is possible to not have a mode within your data set as well, especially when we're using smaller sample sizes. In terms of this slide, what I'm really trying to get across to you here is just a summary of what we've discussed so far in terms of our measures of central tendency and how that relates to our discussion from Chapter 1 about the levels of measurement at the nominal, ordinal, and interval ratio level. What I have here on the left-hand column is each of our measures of central tendency and how you can utilize those with respect to each level of measurement. And so let's go by this one by one. In terms of the average, we would not calculate an average for a nominal level variable. Reason being is when we revisit our conversation about nominal level variables, they are ones that don't have any numerical attachment to them. There's no inherent value to it. Oftentimes they are questions that have a yes or no response. So in that case, you can't really calculate an average or mean value because there aren't any numbers to calculate. With ordinal variables, oftentimes we do not calculate the mean either. However, there are certain instances in which we potentially could if the ordinal ranges had numerical attachments to them. But those examples are very far and few between. So overall, we oftentimes do not calculate the mean for an ordinal level variable, but we would for interval ratio. Again, we saw this with our average net worths within our previous examples in this lecture, and really any interval ratio level variable you can think of could have an average calculated for it, whether that's average GPA, average number of hours spent studying per semester, per week, whatever it is. You can always calculate an average if there is a numerical attachment to those variables. In terms of calculating the median for a nominal level variable, again, since there isn't a ranked order like there is for ordinal and interval ratio level variables, we can't determine the median for a nominal level variable. But we can for both ordinal and interval ratio because, again, there is an order that makes sense to us. And we can, because of that ranked order, put them from a category of highest to lowest, and find what that median or 50% value actually is. Lastly, for the mode, this is the measure of central tendency that we can find regardless of the type of level of measurement that we're dealing with. We can find the mode for any of these. Reason being is the mode is simply looking at what is the most common value. So it doesn't matter whether or not that most common value has a numerical attachment or not. It's just simply what is the observation that has the most times that it's been repeated. So, for example, if I asked you all as a group of students if you're more dog people or cat people, and the responses were more in favor of dog people, then we would have our mode be dog people. We can also do that in terms of ordinal and interval ratio level variables as well, because if we have a repeating numerical value, and that's the most common that we see within a data set, that would indicate our mode as well. I want to wrap up our conversation about measures of central tendency with this idea of skew. And skew is the asymmetry in a distribution of data points within the data set itself. It indicates how much the distribution deviates from the normal distribution, which is a concept we'll get further into detail in Chapter 5. Skewness can be either positive or negative, and we'll get into an example of this on the next slide. The way that you can determine whether or not there is positive or negative skew depends on the direction in which the data points are stretched. And let's take a look at that right now. Positive skew occurs when our median value, which in this case is represented by MD, is less than our average or mean value, which is represented by X bar. Let's think back to our example of average net worth from earlier in this lecture. When we added Jeffrey Bezos to our conversation of average net worth, he pulled the average net worth of that sample, an other group of 10, way up. We increased our average net worth from about $32,000 to over $17 billion. His data point is so off the charts that it doesn't even account for it here. He's basically the highest you can get. In this case, because of that, he's increasing our average. But the majority of our data points were clustered here. No one else within that particular sample was even close to that value. Whereas a negative skew occurs if the majority of our data points are clustered on the positive end, but we may have some smaller values that are skewing our average, again represented here as X bar, to be lower than what the median value, again MD here, actually is representing. Importantly, you'll hear these terms be interchangeable, both within the context of this class and also your textbook. So a positive skew is also called a right skew, which the way I like to remember it is if I had a little skier guy here go off the cliff, what direction is he going down? In this case, a positive skew is going down the right side of the mountain. So that's a little trick I like to remember it with. Whereas a negative skew, my skier is going the opposite direction. They're going left down the mountain. And again, this occurs if the majority of my data points are on the higher or more positive end of the distribution, but I have a couple smaller data points that are pulling my average less down here in complete opposite direction of what we dealt with here with Jeffrey Bezos. The idea of a normal or symmetrical distribution is what you're seeing here with this bell-shaped curve. That means that the mean and median values are exactly at the same center point, and there is an equal amount on both sides of the distribution. We will be talking about this more again in Chapter 5, but just know that this idea of skew comes into play when we deal with both our mean and median values and whether or not they are skewing it in a positive or right direction or a negative and a left direction. As we wrap up our conversation about measures of central tendency, we have reached our summary slide. In this case, this is a good opportunity for you to check in with yourself and see if you're able to answer the following questions now that we've covered all of the material. In this case, can you identify our three measures of central tendency, being the mean, median, and mode? Are you able to calculate the measures of central tendency from a data set using both raw data, so just the column answers, versus a frequency distribution. We also had a conversation about the advantages and disadvantages about certain measures of central tendency. Specifically, we talked about how the mean or the average value can be influenced by extreme or outlier values. So know how that can impact your overall interpretation of a data set, especially in small sample sizes. Whereas the median is that 50% threshold, or that true middle value, and how it can be advantageous for us to actually use that to describe the central measure points because it's not as easily influenced by those extreme values. And lastly, we just wrapped up with our discussion of skews. And so if I were to show you a visual of a distribution, could you identify whether or not it was negatively, positively, or symmetrically distributed? In this case, if you're not able to, or if you have any other questions about any of these other aspects of this lecture, please feel free to reach out to me, and I look forward to talking to you in our next video.